Hi guys, welcome to the channel Understanding Concepts of Physics. We have been doing kinetic theory of gases since a few videos, and today we are going to just move forward with that topic, kinetic theory of gases. Just to remind you, in case you haven't subscribed to the channel, you can go ahead and subscribe the channel and you can follow me. And just a request, in case you haven't watched previous videos, please go ahead and watch the previous videos and then come back to this. There is always a link between multiple videos. Okay, so today we are going to discuss only two topics. That is, one is the emissive power, and the other is called as the emissivity. Okay, emissivity. Now these two topics are needed in order to go forward with other topics. So let's quickly jump to the first topic, that's the emissive power. The amount of heat energy that a body emits in a unit area and a unit time. So for a unit area, unit time, at a particular temperature, at a fixed temperature, is called as the emissive power. So emissive power is the amount of heat energy emitted per unit area per unit time at a given temperature is called as emissive power. So the amount of heat energy emitted per unit area per unit time at a given temperature is called as emissive power. So emissive power is equal to Q upon AT, where A stands for area, T stands for time, and Q stands for heat emitted. So let's say if we have a body and this is emitting some heat energy, then this amount of heat energy is Q, and the area of that body is A, and T is the time. Okay, so that's pretty simple. Unit of E, that is emissive power, is energy ka unit is joule, area ka is meter square, and time ka second. So joule per meter square second, or in CGS system, this would be in CGS system, that is erg per centimeter square second. So that would be the unit of emissive power. Then comes the dimensions ka part. So dimensions, if you can see, energy has a dimension of L2 m1 t minus 2 divided by area is L2 and time is t1. So if you just work around this, L2 and L2 gets cancelled, you get L0 m1, this t goes up, it will become minus 1, so that will be t minus 3. So t minus 3, so this will become the dimension for emissive power. Now after that, emissive power of a perfect black body is written as EB. So emissive power for a perfectly black body we denote it by EB. So in some books you will find out that the emissive power is written as R as well. In some books you will find out R, but in some books you will find out its emissive power is written as capital E as well. So but yes, for a perfectly black body we write it as EB. B stands for black body. Then comes one more concept, that emissive power of a black body is greater than emissive power of a ordinary body at a given temperature. So suppose if I have this one body, this is black body, and this is another body, this is the ordinary body. So if you can see, this is one is black body and the other is the ordinary body. Now in this case, suppose if both the bodies are at the same temperature, let's say 300 Kelvin is the black body's temperature and 300 Kelvin is the ordinary body's temperature. Now they both are emitting heat radiations, but the emissive power of a black body, that means this, will be greater than the emissive power of a ordinary body. And the reason is, and a black body has absorbed more amount of energy, so it is going to emit more amount of energy. So that's the reason why we say good absorbers are good emitters as well. So if a body is absorbing good amount of heat, a large amount of heat, it's a good absorber, then definitely it's a good emitter as well. That's why you'll see black surfaces are very good absorbers, and because black surfaces are very good absorbers, they are good emitters as well. That's why emissive power of a black body is always greater than emissive power of an ordinary body. and that should be at a given temperature. So suppose if I have this body which is black body, and suppose this is another body which is an ordinary body, and if the temperature of this is 300 Kelvin and this is 1000 kelvins, then definitely the emissive power of an ordinary body would be greater because it is at a greater temperature. But when we say at same temperature, we will say that the emissive power of a black body is always greater than emissive power of an ordinary body, because an ordinary body has a tendency to reflect as well as transmit, so it is not going to absorb all the radiations. That's the reason why it is doing so. So this is one of the topics in this particular video which we are about to discuss, which is emissive power. Again, the amount of heat energy emitted per unit area per unit time at a given temperature is called as an emissive power. Now the next topic is what is called as the coefficient of emission, or which is also called as emissivity. So if you can see on the screen, you can see coefficient of emission or emissivity. Now this is written as small e, so we write it as small e. The ratio of emissive power of an ordinary body to the emissive power of a perfectly black body. So it's just a ratio. It's the ratio of emissive power of an ordinary body to the emissive power of a perfectly black body. This ratio is what is called as an emissivity or coefficient of emission. Of course, they both should be at the same temperature. Now, so the ratio of emissive power of an ordinary body to the emissive power of a perfectly black body at a given temperature is called as the coefficient of emission or emissivity. So the formula for that is E is equal to E upon EB, where E stands for coefficient of emission, or we also call as emissivity, and E stands for, capital E stands for emissive power of an ordinary body, and EB stands for emissive power of a perfectly black body. Now, because E is a ratio, because small e is a ratio, so the unit for emissive power and emissive power will get cut, and you will get E will not have any unit or dimension. So emissivity is not having any unit or dimension. And yes, if suppose my body itself is a black body, so this will be EB, and EB and EB will cancel itself and you will get a 1. So for a perfectly black body, E ka value is 1, but for an ordinary body, 0 is less than E is less than 1. Now why is this so? Because as we know, E is equal to E upon EB. This is our formula for coefficient of emission. Now as we know that emissive power of an ordinary body will always be less and emissive power of a black body will always be more for a given temperature. So the numerator is always less than the denominator, so the value will always come between 0 and 1. So emissivity or coefficient of emission will have values always between 0 and 1. So that's all for today. This would be the end of today's video. Thank you so much. Hope you have followed it, and subscribe the channel in case you haven't done so, and keep watching. Thank you so much. Bye.